Hello everyone, Reece Robinson here with the Grundfos Technical Institute. Today we're going to talk about proportional pressure control. So here we have a pump performance curve. Here's our flow in our head, and then our horsepower here, or our power. So for example, a lot of us are familiar with constant pressure systems where we're going to maintain a constant head at varying flow rates. This allows us to reduce the speed of the pump and saving energy. So this would be a control curve for what we would call a constant pressure system. So what proportional pressure does is it allows us to reduce the head a little bit further as our flow reduces, because we all know that friction loss is lower in piping as with reducing flow. So as our flow increases, so does our head loss in our piping. So we want to take advantage of this. So proportional pressure control, first we'll talk about what we call linear. So our control curve is going to look something like this with proportional pressure control linear, as we reduce flow, our head's going to be reduced in a linear fashion as we approach zero. So to set up a control curve for proportional pressure control in a linear, we need to establish the head at zero flow. A lot of times this will be a factory default, or it also will be programmable, sometimes both. So for example, to keep things easy, we're going to go for 50 here. So if our flow was reduced down to 50% of our design, so if our design was 100 and we reduce our flow down to 50, in a constant pressure system, our pump speed would be reduced here. So we would go from, for example, 3,500 RPMs down to 3,000, for example. So what happens to our power is we're going to see a pretty big reduction in power by going from constant speed down to constant pressure. The biggest reduction in power you're going to see in most pumps is just by going from full speed operation down to constant pressure. What proportional pressure gives us is an incremental reduction in power. So what we're going to do here is, instead of 100 feet, we're going to go down to here. So if we reduce our flow by 50%, for example, since this is linear and this is also 50%, we would be reducing our head down to about 75 feet of head here. So what that does is that causes our pump speed to go a little bit lower, and what that does with our power is it allows us to reduce our power a little bit further. The biggest jump in power is going to be going from full speed down to constant pressure. So we're going to have another incremental reduction in power by going from constant pressure down to proportional pressure linear. And then the last bit is what we want to call proportional pressure squared. The characteristics of pipe head loss through piping actually follows a quadratic or a polynomial type relationship here. So this would be the control curve for proportional pressure. We'll call that proportional pressure squared. So this will give us another incremental reduction in pump speed down to here, which will give us another incremental reduction in power, taking us from this power level down to this power level. So the big jump going from constant pressure to proportional pressure linear, another reduction in power is going to go from proportional pressure linear to proportional pressure squared. All in all, the goal here with proportional pressure control is to reduce the head as flow reduces. And to do that, you need to establish your control curve by setting a head at zero flow, or understanding what that is if it's a factory default. So hopefully this is of use to you. Thank you and have a great day.